Hello everyone, this is Dr. Praveen Verma from ADARSH VIDYA MANDIR, Mount Abu. Today's our topic is Stoichiometry and limiting reagent. Now, first thing, what is stoichiometry? Actually, this word is composed of two Greek words, stoichion and metron. Stoichion means element and metron means measure. So, the stoichiometry is a part of chemistry and it deals with the calculation of mass of reacted product. You have studied about the law of conservation of mass. So, the mass of reactant is equal to the mass of product in a chemical reaction, and according to that concept we have to balance the chemical reaction. So in a balanced chemical reaction, if we have the balanced chemical reaction, we can find out number of moles or molecules of reactant which participate in a chemical reaction and form number of moles or number of molecules of product in a chemical reaction. So actually, this type of relationship between the number of moles or their ratio is included in stoichiometry. So we can say stoichiometry is the study of the ratio between reactants and product during chemical reaction. Ratios of number of moles of reactant and product. It is quantitative relationship or ratio between two or more substances undergoing physical or chemical change. It deals with the calculation of masses or volume also of reactant and the product involved in a chemical reaction. So in a balanced chemical reaction, the number of moles or molecules which take part in chemical reaction or their ratio represent the stoichiometry of reaction, and these numbers are called stoichiometric coefficient. We can have the simple example here. Carbon plus oxygen gives CO2. So carbon and oxygen are reactant and CO2 is product in this reaction. So if you see, there is only one here and one and one. So it means this reaction show that 1 moles of carbon atoms react with 1 moles of oxygen molecules to form 1 moles of CO2 molecules. So the stoichiometry of this reaction is 1:1:1. Now second reaction we have here, methane plus 1 mole of methane react with 2 mole of oxygen to form 1 mole of CO2 and 2 mole of H2O. So the stoichiometry is 1:2, and these are stoichiometric coefficient 1, 2, 1 and 2. So it is very easy. If we have the balanced chemical reaction, we can find out the stoichiometry of the reaction. Now, next important thing, that we can interconvert number of moles into number of molecules and mass and volume. So for the same reaction, we can say that 1 mole or 1 molecule of methane react with 2 mole of O2 or 2 molecule of O2 to form 1 mole of CO2 or 1 molecule of CO2 and 2 mole of H2O or 2 molecule of H2O. By the use of mole concept, we can easily convert this number of moles into their masses. According to mole concept, the gram molecular mass is equal to 1 mole. So 1 mole of methane means 16 gram of methane, and 2 mole of oxygen means that is 2 into 32, that is 64 gram of oxygen, and 1 mole of CO2 means that is 44 gram of CO2, and 2 mole of H2O means 18 2, that is 36 gram of H2O. So we can say that 16 gram of methane react with 64 gram of O2 to form 44 gram of CO2 and 36 gram of H2O. Now second thing, if we see the mole concept, we know that at STP the volume of 1 mole of gas is 22.4 liter. So for methane we can say if we have the 1 mole, that is 22.4 liter, and if 2 mole of O2 means 2 into 22.4, that is 44.8 liter, and again 1 mole of CO2, that is 22.4 liter, and 2 mole of H2O gaseous state, it means what, 44.8 liter. So we can say that for this reaction 22.4 liter of methane react with 44.8 liter of O2 to form 22.4 liter CO2 and 44.8 liter of H2O. So this concept is useful in numericals. Now there is one simple numerical. The reaction is same. First example as we have taken, carbon react with oxygen to form CO2. So for this reaction here 1 and 1. So the ratio is what, 1:1:1. So the question is how much amount of CO2 is formed when 12 gram of carbon is burned. So if you see the stoichiometry of this reaction, so 12 gram carbon react, 1 means 1 mole means 12 gram carbon, 1 mole of 2 means 32 gram of oxygen, and 1 mole of CO2 means 44 grams. So according to stoichiometry, if 12 gram of carbon react with 32 gram of oxygen, 44 grams of CO2 is formed. And in question I have asked again same, 12 gram of carbon is burnt, it means 12 gram. So by the stoichiometry you can easily say that when 12 gram carbon is taken, 44 gram of CO2 is formed. Suppose you are asked that how much CO2 is formed when 3 gram of carbon is burned. So you can easily find out using the same stoichiometric coefficients or amount. So by the stoichiometry 12 gram of carbon gives 44 gram. So 1 will give 44 by 12. So 3 will give 44 upon 12 into 3. So it will 11 gram. So when we burn 3 gram of carbon, 11 gram of CO2 is formed. And alternatively you can solve like this. 12 gram gives 44. So 3 gram will give X. Cross multiply them. Use unitary method. So 12x and 3 into 44. So x is equal to 44 into 3 by 12. So you will get 11 gram of water, CO2. Now next concept is limiting reagent. You know, in a chemical reaction, the reactant products are not always present according to their stoichiometric coefficient. They may be less or more. So the reactant which is present in lesser amount means lesser than their stoichiometric amount, and totally consumed during reaction, and limits the amount of product formed in chemical reaction is called limiting reagent. By this simple example you can understand the concept of limiting reagent. C plus O2 gives CO2. So if we see this reaction by the stoichiometric coefficient, we can say 1 mole of carbon react with 1 mole of O2 to form 1 mole of CO2, or 1 mole means 12 gram for oxygen, 1 mole means 32 gram, and for CO2 it is 44 gram. So 12 gram carbon react with 32 gram of oxygen to form 44 gram of CO2. Now there are two cases I have just taken here. Suppose I take 3 gram of carbon and treat with 32 gram of oxygen. So you have to find out, suppose 3 gram carbon is taken and 32 gram oxygen, then which reagent is limiting reagent. So you compare this amount with stoichiometric amount. 12 gram carbon react with 32 gram, and here 3 gram with 32. So oxygen is sufficient. Actually it is according to their stoichiometric amount. But with 32 grams O2 we require 12 gram carbon and we have only 3 grams. So it is less as compared to this amount. We require 12 but we have only 3. So in first case carbon is limiting reagent. But suppose in second case you treat 12 gram carbon with 16 gram of oxygen. So when you compare this stoichiometric amount 12 gram. So again 12 gram, that is the same sufficient amount. But here we require, with 12 we require 32 gram oxygen, but we have only 16 grams. So it is lesser than 32. So in second, the oxygen is what? It is limiting reagent. And always remember the product will be determined by the limiting reagent only. So in first case, suppose you are asked how much amount is formed of product. So for 3 gram carbon, you will get only 11 gram of CO2. But in second case, you will give the amount of product according to this oxygen. That is 16 gram is half mole. So half mole of CO2 means 20 gram of CO2 is formed. Thank you.